engineering student from Brazil, and in this learning session I'm gonna teach you about Streamlit, and I hope you enjoy it. Okay, so the learning objectives are to learn how to install and run Streamlit, learn how to quickly build interactive data web apps with Streamlit, learn how to build interactive data visualizations with Streamlit, and learn how to build interactive machine learning models with Streamlit. Okay, so these are the learning objectives of this section, and this is our agenda. We are going to start by talking about what is Streamlit and how to install it, how to run Streamlit on your machine, and then we are going to do some hands-on, some coding. We're going to build a data web app, and we are also going to add interactive machine learning to our application. Then at the end we're gonna have a Q&A section. Okay, so this is our agenda. Let's start talking about what is Streamlit. According to them, Streamlit is the fastest way to build and share data apps. So Streamlit is a tool to quickly build interactive data web apps with no front-end experience at all required. It's all Python, it's all free, and this is their website, streamlit.io. So this is their website. It says that Streamlit turns data scripts into shareable web apps in minutes, all in Python, all for free, and no front-end experience required. So how to install Streamlit? The installation is pretty straightforward. If you have pip installed in your machine, you just have to do pip install Streamlit, and after a while it's done. So you need to have pip installed. It requires Python from 3.6 to 3.8, but of course it's subject to changes, and it's also recommended to use a visual environment. Okay, so in this case I'm using a Conda environment, and if you already have pip installed and want to upgrade to the newest version, you just need to do pip install -- upgrade Streamlit. So it's pretty straightforward. No previous setup required except for pip. Okay, so once we have Streamlit installed in our machine, we can kind of check if the installation went correctly by running the hello application. To run the hello application, you just have to do Streamlit hello. So after a while, it will launch your application. You can also access your application by localhost 8501. Okay, so this is the hello application. It's like a welcome application. You can try to run some of the demonstrations here. You can see that Streamlit has some settings. You can change the theme, for example. Much time here, but you can later on, just to check if your Streamlit application is correct, has been installed correctly, you can run Streamlit hello, and you can see this demo. And there's also code here which you can use to inspire yourself to maybe build something very cool. Okay, so now we have installed Streamlit. We know that the installation is working. Now let's work on our own data web app. Okay, so let's do this. I have created here just an app.py file. In a folder I have this empty.py file, a ML model job_lib file, which I'll explain later on, and the dataset we are using is the Titanic dataset. So we have this the titanic.csv file here. So let's start coding. Okay, to start Streamlit, you just have to import Streamlit as st, is the standard of the documentation. Let's also import some very basic things that every data scientist know. Plot as plt, import seaborn as. Okay, so this is good for now, and let's see if our Streamlit application is working. So let's give it a title. Just creating a string here, basic Python, and to create a title for our application, we can just do this. Okay. Let's also create a description. Let's see, it's a survivorship analysis on the Titanic dataset. So let's also, with Streamlit, you can also use Markdown, which is a markup language, the same that we use for README files on GitHub. And let's save. Okay, we killed our previous application, the Streamlit Hello application, by pressing Ctrl C. And now let's Streamlit demo. Okay, so I accessed the project folder, and I will just run app.py. Okay. Sorry, it's Streamlit run app.py. Okay, so our application is running. We have our title, our description with Markdown, but where are that sidebar that we saw on the Streamlit Hello application? So let's implement this now. To implement a sidebar, you just have to access it through the st.sidebar option, and we can also add a title to it. Let's add the same title that we added before, and let's also add Markdown to it. And let's see that our sidebar will have like the options of visualizations. So we can choose your visualization. Okay. We can just save. We don't need to run again here. It's already running. And you can see here that the source file changed, so we can rerun, and we have the option to always rerun. Let's press rerun. Okay, so now we have the sidebar. But how do we display our data inside Streamlit? Okay, so first of all, we have to load our data. Load data, just a simple Python function. Okay, so pd.readcsv titanic.csv, which I have here. Oops. Okay, so I'm just dropping this column because we won't use it. Okay, so it's working now. We can just do data load data, calling the function, and to see the data frame, we can do this. Okay, save, rerun, and now we can see our data set. Remove the column name. We can interact with this. We can see like some inconsistencies in our data set, but it's no problem at all for now. Okay. But as I told you, every time we do any changes here, every time the user interacts with the application, it will kind of run everything. So in this case, in this particular dataset, it won't be a problem because it's a very small dataset. But sometimes we have larger data sets, sometimes we do much more pre-processing than we do in here. So it's a good idea to use Streamlit.cache. We use this decorator. Okay, so now it's cached. So even if we make some changes to the application, even when the user interacts and this function is called again, like it actually won't need to kind of do all of this again because it will be already on cached. Okay, so let's interact, add some plotting to our application. So we can add a checkbox. We can do it by if st.sidebar. So we're putting it on the sidebar. If you do just like this, it won't be on the main main space of the application, but I want it to be on the sidebar. So st.sidebar.checkbox, and this is the label of the checkbox, and this is the standard value. Okay, so I will set it to true, so it will always be true. So let's see if this is working. Rerun. Okay, so now we have this checkbox. It actually does nothing so far, but we are going to add some logic to it. Okay, so if the checkbox is true, it will run this code. So we can kind of subset the data set. So let's do it some more pre-processing. So Streamlit cache. So I won't spend much time explaining kind of the logic of the pandas stuff I'm doing, so that I can focus on the Streamlit. Okay, so I have created a subsetting function. I want to subset our dataset by sex, whether male or female. So let's call the function subset by sex, passing the data, our data frame. Let's create a header here, male and female comparative. Okay, let's see how it's behaving so far. Rerun. So you can see that since the checkbox was marked as true here, it runs the code inside. Okay, so it creates this header, and once this checkbox is false, the header goes away. We can create a checkbox on the main page just to see if we want to show the table, show table, which let's set it false, and if it's true, it will show our data frame. Okay. Let's save. So the default is set to false, so the checkbox isn't marked, but I can mark it and it will show our subset tables. But now let us do some plotting. Okay, so we can let the user choose our plot. So we are creating a radio button. So choose your plotting tool here. And as a second parameter, we state our options. So pyplot or plotly. Let's create another header here. Survivors and non-survivors by sex. Okay, so if plot choice. is pyplot. We are going to do a normal seaborn and matplotlib plot. So let's read our figure. Okay, so to display our matplotlib figure, which we created here, and we created the figure here, we edited the figure here, and we are going to display it with Streamlit with this code here. Okay, let's save and let's see how it behaves. Okay, so our plotting tool is pyplot. So we have a matplotlib plot here. We can kind of increase the size, but we don't have our plotly plot yet. Okay, let's add it. Let's import plotly.express as px. Save. Okay, so if the choice isn't pyplot, we are going to create our plotly plot. Okay, so I've created my plotly express figure here by px.bar using the sex subset dataset. The y is the count, the x is the sex, and the bar mode is group. Okay, so to display our plotly chart, we just do st plotly chart and the figure we want to plot. Okay, save, rerun. Okay, so we have here our pyplot plot, but now we have our plotly plot. It's loading. Okay, so now we have our plotly plot, which is kind of similar to the pyplot plot, but we have some extra interactivity that comes from plotly itself. But let us add some more interactivity, more options of visualizations, because we have a sidebar dedicated to let the user choose the visualizations he wants to see. So let's add more stuff to the sidebar. So everything that you can add to the main Streamlit space, you can also add to the sidebar. Okay, you just have to add this dot sidebar before the widget that you are using. Let's do an analysis by fares. Let the default value be false. Okay, so let's get the minimum and the maximum fares. So now we want to add in a slider. So let me just show you how we create a slider. So we have st slider, and let's see fare range here. So it goes from min fare to max fare, and I can also choose where the slider starts. So let's say it starts at 100, and I can have only one slider here. So let's Let me show you. Let us activate the analysis by first. Oops, okay. So it has to be a float. Okay, so our slider starts at 100, but I want you to choose the fair range, okay? So instead of a single value here, we can use a tuple with the max fair divided by 2. Okay, so now this is what I have. I have two sliders, and this slider widget, it will return to me the value that the user chooses. So we have the lower value and the upper value of this slider, okay? So let us subset our data set by the values that the user chose. Okay, so this code will only return a subset where the fair from the data frame is between this range, the lower and the upper. Let us create a fair subset. Okay, so we are subsetting by the values that our slider gives us. Let us write the number of observations that we get from this subset. Remember to always save, okay, because when you save, your Streamlit application will immediately recognize this. So now we can interact with this. So we can see that between this range, we have only 8 observations, and we can increase the range. Okay, so let us do another table here, st.any. Let us create a checkbox. Show table, oops, false. Okay, so it's the same thing that we've done before. Okay, so now it gives us an error. So it says that there are multiple identical st.checkbox widgets. So it happens because we already have a checkbox just like this one. Show table, set false. I actually, okay, so it's here. So it's the same checkbox. So in order to differentiate our kind of similar checkboxes, we can define set keys to them. So we say that this key is 0, save, rerun, and now it works. Okay, so it's correctly in subsetting, and we can interact with it. But we can also do some visualizations with this. Okay, so let's see. Let's create another figure here. Let's add a title to it this time. Again, we use st.pyplot and we pass the figure as the argument. Save, rerun if always rerun is off. Let's hide our table. Okay, so we can see that we can interact, and as we change this, the plot also changes. Okay, so we can see the number of survivors increased. So we can see that within this range we have much more survivors. But if we kind of increase the range to get lower, better values, the number of survivors decreases. So it's an interesting analysis. So imagine that if you are building your own application, it can be anything you want here, like years, if you are kind of a time series. Okay, so it depends on the data set and depends on what you want to build. Okay, so let's add more stuff to our sidebar. So again, if st sidebar checkbox. This time we're going to do some visualizations, compare the family aboard. By looking here at the dataset, we can see that the observation, the person, the passenger could have siblings or a spouse aboard and parents or children. So we are going to do an analysis with it. Let's create a header for this section if it's true. Okay, but save, rerun. Okay, but what if we want to kind of display more than one chart like side by side? Okay, this is possible. Of course, this is possible with matplotlib. You can use subplots, but let's suppose that kind of tables or images or anything you want, you can put them side by side like a real dashboard, and we are going to see how to do that with Streamlit. We're gonna create like the st.beta columns. We are going to create two columns, and this thing here, if we set the parameter as 2, it will return a tuple with the column 1 object and the column 2 object. And we can add stuff to the separate columns. Like instead of using st.something, we use like call1.something. Okay, so let's see if this is working. Save, rerun. Okay, so we can see that we have two columns now here that we created. Okay, so let's analyze kind of what we have here. We have some discrete numbers that range from 0 to 8 in the case of siblings or spouses, and that range from 0 to 6 in the case of parents and children. So we can create a multi-select. So let's see how to do it. Call 1, so instead of st we use call 1 because we want it to be only on the column 1. Let's call it quantities. And we can kind of give values to it like 0, 1, 2, 3. Save, rerun, and now we have this multi-select. But we don't always have like 0 from 0 to 8. There might be some values that are missing. Okay, so we want to get only the values from here. So instead of kind of create manually this list, they're going to use data. So we are going to get the list of unique values, and we are also going to sort it. And we are going to do the same for the second header. So we are doing the same thing here. We are just setting a different key, and let's see how it behaves. Save. So we have an error here, just a typo. Okay, sorry, this isn't a header, this is a multi-select. Okay, so now this is working. We have from 0 to 8 with some values missing like 6 and 7. Okay, so now it's working, and we can kind of put some plots here separated by column, and you can also use more columns like 3, 4, anything you want. You can use how many columns you want to, but let us get the input from this multi-select. So okay, so we are getting the list of values chosen. So the multi-select works like this. When I choose a value, it will kind of hold every value that I choose. So I want 0, 1, 5, 8, 8 here, for example. So this can be useful, for example, if you want to subset your data by country or by state. You can put some categories here. I know this kind of multi-select isn't the best interactivity tool to use here in this case, but I'm just showing you some of the options available at Streamlit. But this works better for categorical information like country or state. Okay. But let us continue, okay? So now we are going to build a plot. We need to create kind of a subset by family function. Okay, so we are subsetting here by the every value that the user chose. For example, 0, 1, 8, so it will create this subset. If it's empty, we are going to prompt an error. Okay, so you can use string st.error. Let's see how it behaves. Okay, let's call this function first. We are also creating a new plot here with our new data frame that we are creating. We're kind of doing the same stuff that we've done before. Okay, so now we are going to do something different because we don't want to plot it like in the middle. We want to plot it only on the column one. So we are instead of st.pyplot, we are calling col1.pyplot. That's the column that we created here. We are passing the same figure, plt fig, and we are use column width, and we are going to set it to true. Okay. Okay, but before we forgot to add a return here, so return df. Okay, so now it's supposed to work. Okay, so now this is working, and we can add more data here. And maybe we can see if like higher values of siblings and spouses lead to higher survival rate. Or we can check if this is the opposite. Okay, but we can also do the same thing for the column 2. Okay, so let's copy here. I know I have a lot of code repetition, but it's just to show you like the basics. We are just prototyping. I also recommend that when you are developing some visualizations that you use some other environment like maybe Spider or Jupyter Notebook or Colab. But you can also use Streamlit. But as for myself, I find it easier to prototype the visualizations somewhere else, and then I pass it to Streamlit. Okay, so I just changed the column here to parent children aboard column, change the name of the df. The rest is the same, but I also have to use on column 2 here, not column 1. Okay, so if it doesn't have any value, it will ask for me to select values like I told the program to do with st.error here, but it's working. Okay, so it all depends on your data and your creativity, but you have a lot of possibilities here. You can have more columns. You can do like a very nice dashboard and report if you want to, and all of it with interactivity. Okay, so you have like almost endless possibilities. Okay, so let's learn how to deploy an interactive ML model to Streamlit. Okay, so how the user can kind of interact with it. and how we can make our Streamlit application perform inferences. Okay, so here we have our joblib file. Okay, so let us first import joblib from joblib import load. Okay. Let us create another checkbox on the sidebar. Okay, would I survive the Titanic disaster? Let us set it to false. Okay, so we have this new option here. Okay, so we have this new option here that this header prints this header like, would I survive the disaster? I'm gonna show you very quickly the features that I used to build the model. I'm not gonna show you into details how I built the model. Okay, so I used scikit-learn version 0.23. Okay, this is the simplified dataset. So I built a random forest classifier, and these are the features that I use, like just the class, age, if siblings and spouses are bored, if parents and children are bored, the fair, and the sex. Okay, so I've used the pandas get dummies, so the sex was like this, just male and female, and I use pandas get dummies so that we kind of have this hot encoding. So these are basically the features I have. It's not a very complex model, it's very simple, and I have kind of fitted the model, I trained, I got the score, and with joblib I exported the joblib file. I called it rf.joblib, and this is the joblib that I have here. Okay, so how will the user input? Okay, so depending on what you need, you can, for example, if this is an image classification problem, you can ask the user to upload an image, or maybe if it's a text problem, you can ask the user to kind of write a text or copy a text. But since this kind of has many different values, we are going to build a form. So how do we build a form in Streamlit? Okay, Streamlit has this a widget for this. We are gonna call it ML form, and we are gonna put it in a variable. And then we have this object called f. Okay, so uh, these are the features that we need: the class, age, siblings and parents, fair, and the sex. So let's do it. So let us get the class first, and we can use a select box and let the user choose the class. And we can also write the values here, the options, which are class 1, 2, or 3. We can also create a sex. We can option. We can use a radio button here. Sex. Oops, it should be a list. Male or female are the sexes available in our dataset. Okay, so let's see our application. Okay, the form is asking for a submit button, so let's add it. we can just kind of do this. Oops. And we can add a label to our button. We can call it wherever we want. Okay, so now we have our submit button. But let us continue with our. So as you remember, we use that like pandas get dummies for the sex, so we kind of don't have only male or female. We are not passing male or female to the model. We have two columns, sex female and sex male, which can be either 0 or 1. Okay, so we are going to do this. We are gonna add a simple logic here. If sex male, we are gonna do this. And also the opposite. Okay, so now we have created like this simple logic. Just if with the radio button I choose male, it will set sex female to 0 and sex male to 1. And if I set the radio button to female, it will set sex female to 1 and sex male to 0. We're also going to use a slider to get the age. So we have used the slider before. So the minimum wage here will be 0 and the maximum will be like, okay, 120. We can also get the number of siblings and spouses. So the user can kind of say how many siblings or spouses they have aboard. Okay, so I'm gonna set it from 0 to 10. I think 10 siblings and spouses aboard would be too much, but okay, let's keep it up to 20 to 10, I mean. And also parents, children. As you might recall, on the dataset the maximum we had was 8, but let's kind of imagine that the user wants to put more than 8. Okay. And we are going to do the same thing here. We are also getting the fares. So remember that we already have a function to get the minimum and the maximum fares. Get fares min max. Okay, this function is also on cache, so we won't have any problem calling it again. Let's also do a slider here. And let's set the slider default to 150, just because for no reason at all, but I think it will look nice. Save. So yeah, we actually got an error here. Let's see. Okay, I already see it. For I in range, okay. Okay, so it's working fine now. Let's see, save. Okay, so I can choose my class. Let's say I'm class 2. I am a male. I am 44. I have 3 siblings and spouses aboard. And I have 2 parents aboard. And I paid this value for the fare, okay? So let's see what else we have. Kinda now we just have to add some logic to the submit button because it's currently doing nothing. Okay, so we have to give it a name to this button. Okay, so we're gonna kind of create this variable submitted that once we press go, the button go, or let's call it submit, it will set this variable to true, and we can add some logic after this. If submitted is true, I will create like a data, my data. Okay, so I create a numpy array with p class, age, siblings, spouses, parents, and children. Pair, sex female, and sex male. These are the features that I use for my ML model. So I'm gonna try to make the prediction. Okay, so I actually have to load the model first. Oops, not here. Sorry. Okay, here I'm gonna load my model. I'm gonna create a function called. No, I won't create a function. I'm gonna just clf load rf.joblib, which is this file that I exported with the joblib library. Exported the model that I have created with scikit-learn. Load joblib. Okay, so now I can use this classifier that I have created, that I have loaded, that I call the predict function with my data. Okay, so if prediction zero, if the prediction is 0, it means that I would have not survived, so I'm gonna kind of send a message like, sorry, you would not survive. And that's sad face. Else, gonna display a different message. Like I'm using arrow and warning just to change the colors. So arrow will be a red message and warning will be a white message. Okay, so you're gonna see how it's gonna look like. You would survive. Okay, so it's celebrating your survival. So let's see, save, and let's see how it behaves. Okay, so let's say I am class 2, male. Let's submit. It's running. Sorry, you would not survive. Oh man, it sucks. So let's suppose I am female. Let's suppose I am slightly younger. and paid a higher fair price. Let's submit again. Okay, so it says I would have survived. So this is great. So we have a functional prediction tool here. Even though the model isn't very complex, it's not working that well, but it was just a demonstration. Okay. I hope that you enjoyed this kind of Streamlit form. This is a kind of a new feature. So Streamlit is a very fast developing library so far. It's developing very fast, and it's always adding a lot of nice new features. So we've done a lot of stuff. We've kind of created some visualizations, we displayed some tables, we create kind of uh, some dashboard features like showing it on different columns. We learned how to display error messages, and we also deployed our ML model in a way that a user can interact and obtain predictions from it. And this is only kind of a small part of what Streamlit can do. There are many other widgets that you can check on the documentation. Uh, like I said before, we have a lot of possibilities. So as you probably noticed, most of our code is mostly kind of pure Python, or Python with pandas, Python with NumPy, Matplotlib, Seaborn. Okay, so you can probably see that Streamlit is only a very small portion of our code, and that's what's so nice about this library, that it's very low code, it's very easy to use. You can focus mostly on Python and the data libraries, the data science stack. So you can do a very nice application without any previous knowledge on front end. You don't need any HTML or JavaScript. You just need to know Python and the Python data science stack. So that's what's so cool about Streamlit. And I hope this gives you a nice introduction so that you can build your own applications, and you can do many other interactive and dynamic dashboards. So this was just a very brief and gentle introduction so that you can know what uh, Streamlit is capable of and kind of how to interact with everything that I showed here. You can also already go into the documentation and explore the other widgets and be creative, get creative, do what you can do and what your data permits. Okay, so thank you. That's it, guys. I hope that you enjoyed, that you learned something new. I'm also free to answer your questions, so feel free to ask. And thank you very much.